So welcome you all. In today's class, we are basically going to deal with the optical communications, having a code of KEC 058. So this is Dr. Nimish Kumar Sriva, Assistant Professor in Ajay Kumar Garg Engineering College. So let's start with the session, and we will discuss first of all what are the basic syllabus that we have to cover, and after that we will start with the basic introduction of the optical communication. So this is basically the syllabus of optical communications that we are having. Basically, the first unit of any syllabus or a topic is subject is to basically give a brief introduction about the optical fiber communications, and in that we are going to basically discuss about what is the history of optical fiber communications, and step by step what are the advancements that are done in the optical field, and what are the different windows in which optical fiber can be deployed. And after that we are going to deal with the optical fiber communication link. What are the optical components that are used for forming a complete optical link, and meanwhile we are also going to discuss what are the advantages of optical fiber communications, and the last thing will be your applications of optical fiber communications. So this is basically all the entire units of optical fiber communications that we are going to deal in this module of optical fiber communication subject. So let us start with the history of communications, as we are dealing with the optical fiber communication. So first of all, we have to understand what is the history, what are the past development that are done in the field of communications. Only after that we could be able to understand that what is optical communications, what is the history of optical communications. So the very first form of communications that are done, that was basically in the 1705, and in that basically the persons, they were using a mirror for communications. Like there will be one people standing after some distance, and with the help of a polished bronze mirror they are going to communicate with each others. Apart from this mirror, there was another mean for transmitting the informations, was a fire beacons. In that fire beacons, various flames that they are using, various color flames that they are using to indicate some different kind of informations. Apart from that, we are also having smoke signals, some various kind of smoke signals that are used by in the age of 1705. So apart from this, after this, in 1792, the person was a Claude Champ, and he uses optomechanical way of communications. What is basically he had done in that system is that he have used a Semaphore devices. So basically what is happening in a Semaphore devices is that it's some kind of communication that are done with the help of a flag. So basically different gestures of a flag will be there. I mean, a person will be standing having two flags in his hand, and with the position of that flag he is going to indicate a particular letter. So various letters that are used for transmitting information is given in the slide. So in this communications, what is happening, as for the communication done using a semaphore, a person have to use a flag, and definitely in order to transmit information for several kilometers, there have to be lots of number of persons in order to communicate with each other. There have to be a group of peoples, and also the important criteria is that there should be a line of sight. If a person, two people are standing beyond their range of a line of a sight, then obviously the communication can't be established. So in this, for establish a complete communication link, what is happening, we require a more number of persons. So basically the first communication link that was established in France, and in that case they were using around 200 relay stations. Relay stations means at each and every stations there have to be one person standing with the flag, and the position of that flag will indicate what kind of a letter that is going to transmit. So obviously the faster the rate, the rate at which a person can change the position of their flag is it's not going to be high, because at a how much faster rate you can change the position of a flag. So the transmission rate of the information done by using a semaphore devices was less than 1 bit per second. Obviously, it should be less than 1 bits per second, because a person how fast he can change the position of flags with the help of his hand. Although the first communications, it is the communication that has used optomechanical. Opto means it's basically we can see the communication, so that is called as opto, and mechanical means as with the help of a motion of a hand we can communicate the different letters. So after this, the electrical form of a communications that has came into existence, and basically there was a telegraph that was developed, and they were using a Morse code. In that Morse code, what is happening, there will be a series of dots and dashes, and each particular series of the combination of dots and dashes is going to represent a particular letter. So obviously a person have to be developed excellency in this case of understanding the Morse code. Only then he can transmit the informations. So the rate at which information can be transmitted in the case of a Morse code is 10 bits per second. And that was the first transatlantic telegraph that was established in 1856. Now, although it was the first transatlantic telegraph transmission, but it was a big failure. Now, what is the reason? What is the reason of big failure of this transatlantic telegraph? Is that two persons were standing at the two continents across the seas. They have to transmit the information. So the problem with them is that one person was using a code or the frequency that is much lower than, or the strength much lower than the person who was transmitting information, a person who was farther apart from him. So there was a mismatch for the voltage at which one particular person is transmitting. So the two persons sitting at the extreme continents, they were transmitting the information with the help of this electrical communications. The problem was that one person was transmitting the information at a much higher voltage, whereas the other person was using a lower voltage, as its devices were designed in such a way that they are going to handle a low voltage. So if that is handling a low voltage, so obviously the persons that who is sending the information with very high voltage, they are definitely going to damage the person who the device of a person who was using the voltage at a much lower level. So that was the big failure, because there was a mismatch between the transmission of a voltage, as in order to give the information of a one person that I'm using a low voltage, so you also have to send the information at a low voltage. Now this could be done only with the help of ships going across the sea. So it's going to take around 1 month to travel across the seas and give the information to a particular person that I'm using this voltage, so you also have to send the information at this particular voltage. So that's why, because of the mismatch between the communicators, because of the mismatch between the voltage at the two extreme ends, that was a big failure. So after this, in 1876, twisted pair cable came into existence. So they have increased the bandwidth capability. Now after that, in 1940, a coaxial cable was introduced, and that could handle 3 megahertz. The frequency that it was using a 3 megahertz. So if it is using a 3 megahertz bandwidth, so obviously at one TV channel that can be transferred to this link, or equivalent to 300 voice channels. Now this coaxial cable also provided a main bandwidth increase in the communication history. Now after this, obviously because of the demand for more and more bandwidth, there came another mode of a frequency of a communication, which is called as a microwave communications. So in that microwave communications, also the frequency could be will be above 1 gigahertz. So basically they are ranging from 1 to 10 gigahertz of the carrier frequency. So if the frequency range has increased to 1 gigahertz from 3 megahertz in the case of coaxial cable, the speed at which you can transfer the information will increase, and that increase in speed is the 100 megabits per second. Now after this, because of this 100 megabits per second, the repeater spacing has been increased to 1 kilometers. So means that, what is the meaning of this? Repeater spacing is between the two points. If you are transmitting information from one point to another point, and the distance is around, suppose that it is a 10 kilometer. So if you have to transmit the information for 10 kilometers, you have to definitely use a repeater at a regular interval of spacing, because after some distance, traveling of some distance, definitely due to some external interference and because of some noise will be introduced inside the communication channel. So if some noise is introduced inside the communication channel, so obviously for a proper transmission of information, you have to maintain the strength of the signals, so that even a noise can be removed. So that thing is called as a repeater. Repeater going to basically regenerates your original signals at a regular spacing of spacing. So after this, the need of bandwidth goes on increases. It basically increases. Why? Because if we are transmitting information from one point to another points, we actually want to increase the number of channels or the number of a subscriber that can be used for transmitting the information from one point to the another point. So the major breakthrough in the increase in the bandwidth is in 1960, because in 1960 optical carrier has been given by the frequency of optical carrier has been introduced by different researchers. So after this brief history of communications, now basically we are going to deal with the, as we have discussed that in the 1960s the optical carrier came into existence. Because of this optical carrier, definitely the bandwidth requirement because of the bandwidth requirement, optical carrier came into existence. So as the bandwidth increased, so definitely more and more information can be transmitted. So we got this information that what is the brief history of communications, step by step, what are the different form of communication channel that has been established in terms of wire, that is twisted cable, then we are having coaxial cable, after that we are having microwave links also, and even the microwave links can meet the demand at some certain gigahertz. After certain gigahertz, there have to be some different medium, that is the optical fiber. So in 1960 optical carrier came into existence. Now we are basically now going to deal with the basic history of optical fiber communication, step by step, who gave the meaning of who gave the first word of optical fiber, and after that what are the steps that are that is carried on to increase the bandwidth of the optical fibers. Obviously the bandwidth, the optical fiber that was introduced very first must be having a several kind of attenuations. So the first word of a fiber optic was coined by the researcher, that is Narendra Kapni. In his PhD thesis, he had used the first word of a fiber optic, and although the fiber optic that he had used, it is not basically for the communications. That word was used for imaging, that means in the form of endoscopy. So they have used the Narendra Kapni had used the first coined the word of fiber optics, although they had not used the word fiber optics for the communication. Remember this. So in 1956, first time this word of fiber optic came into existence. Now after 1956, 1960, that because of the development of laser by Theodore Mammon, they provided a major breakthrough in the field of fiber communications. Now after this, in 1964, the two scientists, that is a Cow and Hockham, so they suggested the glass fiber for the optical fiber communications. So now they have suggested the glass fiber because that glass fiber can give a low loss. I mean, a glass fiber is a material that give a low loss for the low loss to a signal. So if you want to transmit a signal from one point to another with a very low loss, although you know this, the major advantage of optical fiber is that it has provided a very huge increase in the bandwidth. So now if it had provided a very huge increase in the bandwidth, obviously you need not only the bandwidth is the requirement, you have to transmit the signal with a low loss. So first time Cow and Hockham in 1964 suggested the use of a glass fiber as a mean for communications in the optical fiber, as it is providing a low loss. Now after this, in 1970, Corning the glass fiber optical corning glass optical fiber with a loss around 20 dB per kilometer was commercially deployed. So what is the meaning of a 20 dB per kilometer? So if I am saying I am transmitting a power from one point to the another point, launching the power inside the optical fiber, and if its strength is around 100 milliwatt, and that fiber through which I am transmitting the information is having a that the property of that is going to introduce a 20 dB per kilometer loss. So meaning that 20 dB per kilometer, if you are converting into terms of a milliwatt, it's definitely going to 100. So that means whatever the power that you have introduced at the input side, and at the output side, you will get 100 times reduction in the input power. So that is the this 20 dB per kilometer loss is comparable with the coaxial cable or coaxial cable. So if it is comparable with the coaxial cable, so we can use optical fiber as a transmission medium. Why? The question is why? If it is a comparable, we already having a coaxial cable with on our side. So why we are going to use optical fiber? It is only because of the very huge increase in the bandwidth. With the increase in the bandwidth, you can transfer, or you can increase transfer more number of information from one point to the another point. So in 1983, this commercial deployment of optical fiber in the northeast corridor was done in the 1983. So now in 1986, the first Rbm doped fiber amplifier was deployed, and it was the reservoir and the David. Now it is a major breakthrough in this the optical fiber communication, because you have to use an amplifier for increasing the strength of the signals. If you have to increase the strength of the signal, because some kind of noise may be introduced in the signal, while it is transmitting through the transmission through the medium. So this Rbm doped amplifier basically that is used at the 1550 nanometers, and it is used for single mode as well as the multi-mode fiber. This provided a major breakthrough in the field of optical fiber communications, because they are going to increase the strength of the optical signal in whatever the optical signal that is transmitting inside the optical fiber communications. Now after this, what is happening? In 1996, commercial WDM system came into existence, and it is the capacity, the number of bits per second that it can transmit is around 100 gigabits per second. So it's there's a huge shift in the speed of the transmissions. Now after this, that in 2007, various advanced modulations format that came into existence, and it were having a capacity. Those standards were having a capacity of around 100 to 400 gigabits per second. So this is all about the basic development, step-by-step development in the field of optical fiber communications. Now once we have got the basic definition, basic overview about the history of a communication as well as the history of optical fiber communication, now the next thing is that we have to understand that step by step what is the increase in the way of reducing the attenuation of the optical fiber. So we are basically having, there are three different windows that is basically used in the optical fiber communications. It is ranging around 800 to 900 nanometers, and apart from that, with the help of this bar, you can see that there is a first window, second window, and the third window. So in at least 1970s, the first window that was used in the optical fiber communication, that was ranging from around 800 to 900 nanometers. But the problem with this window is that it is providing a attenuation of around 5 dB per kilometers. So 5 dB per kilometers is also a good form of that can be bearable by using an optical fiber communication, because it has provided a very huge shift in the bandwidth. Now step by step various changes took in the optical fiber. That means various form of purification done, and various removal of the moistures from the fiber during the process of fabrication. Because of that, there was a gradual decrease in the attenuations in the 1990s, that is around the window of 1300 to 1350 nanometers. So this was providing a attenuation of around 0.4 dB per kilometer. Now, even after that, various researchers keep on purifying the optical fibers, and finally they have attained a window which can provide a low attenuation as low as a 0.2 dB per kilometers. So basically, three windows that are used for the optical fiber communication. First is your 800 to around 900. In that, the major was around 850 nanometer, that was providing around 4.8 dB per kilometer of attenuations. After this, there was a second window which is around 1300 nanometers. Now this is also providing provide a huge reduction in the attenuations. It is ranging around 0.4 nanometers. Now the main window that is used for optical communication is this one, third window, which is ranging from around 1500, this is 1500 to around 1650 nanometer, right? So in this range, the major point is the 1550 nanometer that is used at present in a single or in a optical fiber for the proper communications, because it provide a 0.2 dB attenuation per kilometer. So this is the basically a wavelength that everyone going to use for the the proper transmission of a signal in the optical fiber communications. Now this is the basically the history of attenuation, how step by step as the time increases, what was the basic advancement in the done in the field of material of optical fiber, purification of optical fiber, and as a result of that, step by step there is a gradual decrease in the attenuation that was introduced per kilometer in the optical fiber. So now, after getting this information about the history of attenuation, now we have to understand why we are using optical fiber communications. I mean, there have to be a need, because of which there have to be need, because of which this optical communications introduced. So the need was that bandwidth. In the case, suppose that we are using a carrier frequency of around having a bandwidth of around 2 megahertz, and we want to transmit a voice channel. So voice channel, we know that it's maximum for a proper transmission of a voice channel. Suppose that we have used a 4 gigahertz of the frequency. So now, if we are using a 2 megahertz transmission bandwidth, and the voice channel is the frequency that we want to transmit with the help of for transmitting a voice signal is 4 gigahertz. So the number of voice channel that can be transmitted. So the number of voice channel. We want to know the number of voice channel that can be transmitted simultaneously is number of voice channel that can be transmitted simultaneously will be 2 megahertz, that is the bandwidth of a channel, and we want to transmit a 4 kilohertz frequency. So it is around 4 kilohertz frequency. So it is around 500 voice channel that can be word signals that can be transmitted simultaneously through we are using a 2 megahertz channel. So now, if we are shifting from a megahertz, that means in the range of a microwave, and we have gone to a 2 gigahertz frequency. So if we have increased to 2 gigahertz, and so the number of voice channel that can be transmitted, simultaneously with the help of, if we are using a 2 gigahertz of a frequency, So it will be around 500 and then 1000. This will be the number of voice channel that can be transmitted simultaneously through the bandwidth of 2 gigahertz. Now we got this information. As we increase the frequency for the transmissions, we can conclude that the number of voice channel transmitted simultaneously can be increased. So we have shifted from a megahertz to a gigahertz, that means to a microwave signals. Now after this microwave signal, that is gigahertz, we have shifted to a terahertz. So now also the bandwidth as increases to a terahertz, definitely the number of subscriber, number of voice signals that can be transmitted through this link will also going to increase tremendously. So that is the base for the need of a optical communication, because in optical communication the bandwidth has increased. If you have increased the bandwidth, the number of voice channel transmitters simultaneously going to increase. So we are going to continue from the next point here. That means in the next class we are going to discuss about what are the basic components that are used in the optical fiber communication. So thank you all.